All right, welcome everyone, and thank you for joining us on Dave Cooper Live, where we bring you the people, the products, and the process helping you build it better. Hot off our international roadshow, we visited advanced manufacturing facilities throughout England and had amazing views of the London skyline from high-rise job sites and the New Zealand house, where we presented at Steel Horizons, hosted by light steel roll forming machine pioneers, Howick LTD. Also, we're going to welcome Scott Mitchell, founder and CEO at Studio IO, as we dish on all of our learnings from this past week. And we might just talk about generative design, digital fabrication, the changing geometric shape of cold form steel construction. But first, we need to thank our sponsors, Stream Logistics, CombiLift, and Brave Control Systems for helping us to build it better. Carson Holmquist and the team at Stream Logistics, they are experts in high-stakes freight. The new methods of construction need new transportation solutions, and they are up for the challenge. You can find them at streamlogistics.com. And also a shout-out to Paul Short and the team at CombiLift, largest global manufacturer of multi-directional forklifts and straddle carriers, helping companies maximize the safety capacity, safety, and efficiency of their warehouse and storage facilities. Visit their website at combilift.com. And Brave Control Solutions, where offsite manufacturing systems do more than just improve productivity. They have a unique approach to industrialized construction, a lineup of flexible automation systems specifically designed for the construction industry. You can go and check them out at thinkbrave.com. All right, it has been a whirlwind week. Planes, trains, and automobiles, and I mean that with all of my heart. We're going to have a great conversation today. We're going to banter a little bit about what we got going on, and we're going to talk a little bit about something you have not seen on this show before with Scott Mitchell. So let's hop right into it. What's happening, Mr. Scott Mitchell?
Hey, Dave. Thanks for having me on.
Yeah, no, glad to have you. So, man, we just both got back from England. We had a great trip. At least I had a great trip. Did you have a great trip?
Yeah, it was a great trip, man. It was a long trip. We did a lot.
We did a lot, and it was all about trains, planes, and automobiles. So Scott, before we jump into this, before we banter a little bit about the fun and the late nights and the early mornings, I think we need to know a little bit about who you are and what you do. So we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, or we will call your mother, but you only have about 2 minutes to do it. The floor is yours. Go for it.
Thanks. That's a lot to do in 2 minutes. I think working backwards, I'm the founder and CEO of Stud.io. And before that, worked at Autodesk, where I was a software engineer. And before that, I was a student at Washington University in St. Louis, and pretty much studied all kinds of stuff in school. And since then, architecture, computer science, film, and music were the big ones. And I am lucky enough now to have this company that is really all about making things. We do software development. We work in construction. We do a lot of animation as well. It's kind of all come together. So I think like the story of my life leads up to this idea of making things as my passion, I guess. So you guys will see how Stud.io has been a great vehicle for that. Before that, I currently live in Boston, born and raised in Tulsa, Oklahoma. One of 6 kids. So we got a big family. Me and my wife live here in Boston now. We have a 6-month-old kid, James. We have a golden retriever, Lou. And I feel like that's most of it.
Well, not even close to most of it until we get into what you've been doing here. Taking a modest approach on this. So you kind of got thrown into this industry from school. You ended up getting an internship, right, with Autodesk. Is that correct?
Yep.
Right. And Autodesk said, you know what, Scott, you're a bright, tall young man. Here's a machine. I want you to do stuff with it that has never been done with it before. Can you play with it all summer long? I mean, this was kind of the kickoff to where you're at today. Is that accurate?
That's very accurate. I mean, what a fortunate internship to be thrust into, right? I think they just saw it as, might as well have an intern, have some fun so we can hire them back after school. and really was the kickoff of this company.
Yeah.
So it might have backfired on them in the end, I guess, since they did lose me. But anyways, yeah, that's how it all started. And I come from architecture and kind of switched from architecture to computer science before I wrapped up school.
Yep.
And so what's been interesting about, this past week going to visit these different manufacturing facilities and sites is, I'm still learning about construction because I'm coming from the technology side, and we know plenty about construction now. We're about 3.5 years old, but we continue to value working with people who have a deep understanding of construction and a long history there. That collaboration is extremely important. And then going out and just visiting and learning about some of the problems, as well as the solutions already out there. And that's what last week was really great for, from my side.
Well, I think also it was great for, this was all based around steel construction, panelized systems that are being incorporated. And what you have done to improve their capabilities, I think, was very eye-opening to a lot of these really big manufacturers of, and builders out there not knowing what the next level was for equipment they already own that's out there doing amazing things. And we're going to hop into that in just a moment. So, but we are live, Scott, on LinkedIn, YouTube, Facebook, Twitch, and Twitter. So get your tweets on. And if you're not following Scott Mitchell, you're wrong. You should be following Scott. And we need to celebrate the young people coming into this industry, such as Scott, because they are taking a new look and bringing different perspective to how we do things. So, Scott, let's hop right into this. What is computational workflow, and what does that mean to you?
Yeah, I mean, computational workflow, it's pretty much synonymous with parametric modeling. So people have heard of Grasshopper or Dynamo. I actually used to work on the Dynamo team at Autodesk, as well as just like writing your own software that automates some process in design or in fabrication or installation and construction. So computational workflows, especially how we see it, involves a lot of upfront development. So I think what's different from a traditional construction process is that you're investing a lot in the planning stage and pre-construction, including, this might even include software development during a project, like as part of the project. So you get this computational workflow set up in the beginning that has an understanding of the entire fabrication and installation process. And the goal is basically to create a click button, process that's automated from design all the way through construction.
And I'm assuming, and I already know these answers, but what is Steel Stud Studio or IO? So I mean, if you were to talk about what your company does, you guys really wrote software that allows you to handle some of these things. Yes.
Yeah, absolutely. I mean, we're Stud IO because the first computational system we put together was for the Howick steel stud rolling machine. And that's still the thing that we're most capable of. But what we found after a couple of years is that the ideas and the theory behind the software for steel studs also applies to a variety of different fabrication and construction types, like hot rolled steel that goes to a tube laser machine, any kind of CNC process. Mass timber is one that we have our eye on. But the common thread with all of those is that they're basically digitally controllable fabrication equipment. And we're a studio, Stud.io, because we really dive in and explore and experiment with those machines. So what's interesting to see, like even at these amazing facilities that we went to go see last week, people are, for the most part, they've really innovative workflows, but the way they're using the machines is pretty much off the shelf what they're meant to do. So what we do as a studio is when people want to do more than that with their machines, we can come in and we have a suite of software to deploy, and we help develop custom workflows with those machines. Basically, capabilities with machines that even the makers of the machines may not have thought of themselves. And so that's why we're a studio, and that's what we do in studio.
You're rewriting the control manuals for the machines, and that's what I love about this and the software that makes it right.
That's a good way to put it.
Yeah. So, you know, Scott, we're going to jump into a presentation and show you exactly what this is, and everybody can see what this is. But why don't you explain the machines just a little bit so the audience that may be out there that doesn't know what we're talking about can kind of relate what we're doing here. So what is a cold form steel machine do?
Yeah, it's a pretty incredible machine in terms of the scale of stuff it can produce. Takes in a big roll of steel. It's about 8 to 10 inches wide, depends on what you're trying to roll up. And this machine punches holes in it and then folds it up into the C shape of a stud and then cuts it to length. So that's pretty much all it does. But it's a pretty small machine, relatively speaking, for what it's doing. But yeah, that's what it does.
So in our journey, people that are using these machines, some using it for digital purposes and planning purposes, and then others are actually using it to sell products or use products for themselves. So some examples of that, we went to Frameclad. Frameclad is a panelized cold form steel panel builder with several locations, and they do everything from very bespoke products all the way to some of the largest multifamily commercial projects. And then we were at British Offsite, who has this machine, and they are making a wall panel system for high-rise buildings, right? For commercial, residential, high-rise buildings. So we've taken a look at that. And then we were also at Bryden Wood, who is using this almost in the same format that you're using it and looking at it. Well, what is the functionality that we can do with these machines to produce better products? And we're going to jump into all of that here in a moment. So, Scott, I don't know the best way to start other than starting. Maybe we jump right into your presentation and go from there.
Yeah, let's do it. And feel free to comment, interrupt, whatever. Tell me to move on. Anything.
Oh, I will. I'm good at I'm good at interrupting.
I am, I'm sure. So stud out. This behind the big logo there is one idea of a system. That one's our faceted surface system. So you can see this geometry is changing, and all of the components are updating based on that geometry, and that's fully automated. And the other thing you can see here, it's kind of covered up, but there's data associated with that, right? So your quantities that you might need for estimating, and super accurate. And not only does it give you material quantities, because to go from just a quick model to fabrication requires a detailed understanding of the structure and all the different connections and such. So if you know how long a certain connection takes to put together, which is pretty easy to figure out, you can also pull labor costs out of these models as well, which I think is really interesting. So that's at a high level what a system is, a computational system, and the kind of at least in the early stage of a project, some of the value you get from that. That was the Howick machine that we were talking about a minute ago. It punches holes in studs, right? That's what it does. Pretty limited, constrained machine. But what we've done is we take those simple operations that the machine is capable of, those punches, and we develop parametric connections with constraints in our software that allows us to deploy these really versatile systems.
So so people understand that, Scott, normally these machines just print straight studs, put the dimples, the holes, so you can connect them together. If you think about building a wall, it's like metal wood studs, right? It's wood studs that are metal, or maybe that's a better way to say it.
99.9% of what people fabricate with their machines, you could build flat on a table, right? They're building flat frames. They use one connection type.
Got it. And you're taking that to a whole new level, and this is cool stuff. So go ahead.
Yeah. So one of the connection types is this is what we call handshakes, just two studs back to back. You can put these alignment holes together that allow you to fix studs at any angle that you want. But okay, so this part I think is critical. So this is something someone might typically build with just a dimple connections, stud to stud, very typical connection for a steel stud roll forming machine. But if we add that handshake connection in that I was just showing you, we're no longer on the table, right? We're building up out of the plane. And so that idea of being able to start building things that aren't just two-dimensional is really like the key behind all this stuff. So we're trying to enable the most versatile systems that we possibly can, basically so that designers can think more three-dimensionally and know that it can still get built. So I'm gonna kind of skip through some of this, but you can see the output. It actually works, right? So they feed in their geometry. Our software takes care of everything else. You have a file for the machine that gives you the exact parts. It's like Legos to put together. It's a lot of fun to do. We've actually built a lot of stuff ourselves just because it's pretty rewarding to put these Lego pieces together that you've designed. Dave, I think you're muted.
Yeah, thanks. Let me go to a quick question we have right here. So Ben Hershey, what's happening, Mr. Ben Hershey, Forward Solutions Group, an awesome supporter of the Dave Cooper live show and one of the biggest consultants globally in the offsite space. So Scott Mitchell, the software you are developing, is it also performing structural analysis of the structure?
Yeah, that's a really good question, and it's one that we get a lot, and that's something we've played around with. But for the most part, we're still working with engineers to validate structures. But our software works inside of a number of different environments, including Grasshopper, which is a parametric modeling platform that includes parametric structural engineering tools as well. So a lot of times what we'll do is we'll just kind of pair our software with that. And we've done some like structural optimization of trusses and things like that. But I do think, like, for the future, one thing that we definitely have our eyes on is, when you get down to it, our software it's a constraint satisfaction algorithm, which is the main intelligence that's running behind it. And it solves fabrication constraints. But if it could also solve engineering constraints at the same time, it would be a really big deal. Yeah. So that's something that we are definitely thinking about. But there's a lot of development to have that happen in the same process.
Thank you. Appreciate the question, Mr. Ben. I figured it'd be a smart question. They usually are.
Yeah, no, that's a great question.
Yeah,
you asked all the time. So we were talking a little bit about just doing unusual things with the machine, and a lot of times we mess around with the machine. I actually had a teacher in architecture school who, the theme of the semester was, let's misuse machines, which is, I think, the coolest line ever. And it's something that's really stuck with us. And the value that we see there is we just try weird stuff with the machine just to see, is it going to work? And usually does. But it's always enlightening to, you either discover that there's something you didn't think was possible is possible, or you discover, no, that's a hard line right there that we shouldn't cross again. What goes along with that is we've broken a few machines temporarily. We've jammed the Howick machine. I don't even know how many times, but we get better because of it. So to me, this is like, there's a space of potential of various machines, any CNC machine, and there's got this small subset is what people have kind of the defined typical use cases, and we want to go outside of that, and we do whatever it takes in order to kind of grow into this branching out into the space of potential. So like this is probably the best example of that, because the Howick machine was not built to make curved studs, but it turns out it's possible if you just use some of the operations that are included on the machine for other purposes. And the way that works is you do get a straight stud out of the machine, and you just snip one side of it, kind of using these operations in weird ways. But you snip one side of it, you have these two dimple holes that you overlap and put a screw through it, and it takes on whatever shape, any kind of curve that you want it to take on. So
you made all those tables?
We made all these tables. This one, I think, is one of the coolest projects. It's from before Stud.io was founded, but it's really, it kind of epitomizes how we do R&D, right? It's we kind of have fun with it, and there's a sense of playfulness about it. And so for like a month, this was before I started Stud.io, so it was in my spare time after my day job, just sketching out and building weird tables. And what's up, Mark? And it's what I love about it is, one, I think they turned out really nice, and two, it's basically this library of connection details, right? Like all of those things are connected together in unique ways. And those are things that you can pull from that on actual projects.
Yeah, and you guys have done a lot of other cool things. And I think, for people just joining, the conversation here is about thinking differently, using computational design, parametric design, taking things that already exist. We've talked about this. I talked about it during our conversation when we were giving our speech over there. And if people would just look at what's already there and find uses for it within their business that they don't even know exists, that's kind of what you're doing, Scott. You're saying here you can take and do these things with something that you think is only going to print something straight and put dimples and holes in it. And I think this is the kind of thinking we need in our industry, because these machines have been around for a long time. You were just given the opportunity to say, I bet we could do a lot of cool things with this. Should I change the software in these machines? And that's what we're talking about today.
Yeah, that's exactly it. And, we're constantly doing more of that. And a lot of it is finding partners and collaborators who think the same way, which there are a bunch of. It's an ongoing process, but part of it is testing out some of the stuff that you wouldn't think is possible, like building a bird. And the reason we did this, because we had a system that we wanted to see if it was possible to do highly articulate surfaces or geometry like an animal. And it was. But that same system is the system that you see right here. So you should kind of see some of the same details. And so building that bird, it was just done for fun and ended up being scrapped. But it proved that we could do stuff like this, which we use on real projects. So this was an architectural project.
So let me ask you this, what is the accuracy of something like this?
Like more accurate than any of the other components are going to be, unless they're like CNC milled. I believe what Howick is, I've heard Howick quote 64th of an inch, which I wouldn't challenge that. It seems to be accurate.
Right. And it's like Lego. So when you put the details into what you want to build, it prints it out in a specific order. So you know exactly how it's going together, or the person that's installing knows how it goes together. But what I think is really interesting about this is the hybrid approach, right? So we have a lot of volumetric builders, and manufacturers that follow the show. We got steel builders and volumetric steel builders that follow this show. But here's an opportunity when you have a unique project or a unique building that you don't have to outsource it to somebody else because you do not think you have the capabilities to do something custom, or, you have that. If you have one of these machines, or somebody with these machines, it's as simple as putting the data in, printing it out, and putting it together. Because I know, looking at that out of wood, that's complex to, do on site and make happen. And most of the time you're doing it on, scaffolding pretty high in the sky.
I think that's a great way to put it. I mean, if you have digital fabrication equipment in your shop, you can probably do more than you think. Yeah,
very much so. Even Andrew Seeley thinks so. Lots of uses for radius structural shapes and architecture. Hey, Andrew, when you were doing those really cool curves on your project out there somewhere in the middle of Texas, I bet this would have been a cool thing to help you with, huh? All right, go ahead, Mark. Sorry. Or Scott. What did I say? Mark? Yeah. Mark Munns? I'm looking at Mark Munns' comment and calling you Mark and Scott. Go.
We here's a couple just different projects. Just these are the things that are possible with our software and with machines that you may already have. So these are, I'll go back one. This was this museum in California. These things are huge. There's 193 unique panels. And so we built the system. It automates the fabrication of not just that frame. So, but one other thing that like I said, we've expanded into other fabrication types, which allows us to build, in some sense, this is a hybrid panel because it's not just a frame. There are all these other digital files, deliverables for machines to build the rest of it. Like you see on the right side that has a GFRC finish. So there's a mold that you need for that. And it needs to be coordinated with the frame if you want a fully digital workflow. So we handle those molds as well. Crazy staircase, super, super complex project. But what's cool about this one, it came to site, like the ceiling in the front here was 10 different pieces, and they just kind of puzzle piece together inside. So layout, you don't have to think about, right? It's just like putting these 10 pieces together and it makes your shape. This is a faceted surface architectural application. So that's just a whole bunch of the stuff we've done. And then if we want to go into it, this is one of our current projects. We just finished it up in Las Vegas.
Vegas, baby.
Oh yeah.
Sorry, go ahead.
If you've flown into Vegas recently, you probably saw this. It's this huge sphere right by the Venetian. And we were brought on to help with the collar, which is this ring that's highlighted in red at the bottom. And so a couple of things to note about the geometry here is that it's obviously curved and planned. It's going around the sphere. It's also sloped in elevation. So there's some engineering parameters that have to be dealt with there. And then most challenging was that it was tilted in section, and that tilt is variable. So it's leaning out and then leaning back in. So that's something that you have to figure out how to deal with. And basically what we want to put together is a clear path from this design all the way to putting a panel on the building and using digital fabrication at every step along the way. So the system, it was EFIS system. We're going to basically panelize the collar with the EFIS system. I think the most important thing to note here is that those are all flat components, right? So this is typically something that's just put on a flat wall as a rectangle, which doesn't quite work here. So if we break this down, figure out how we're going to put a flat system onto it, just start with a flat wall. Then it's obviously pretty easy, right, to break that into flat rectangles. And even if you tilt that wall out, it's still flat rectangles. But if you put that tilted wall around a curve, you start to run into issues. And say this is challenge number one, which is that they're fanning out in elevation. And it has that gap at the top, which is not good. So just fill that in, make your rectangles into trapezoids, and you're good. But then issue number two, so remember we said that tilt is variable. So that introduces this fanning out in section, which is, I actually think looks pretty cool, but it was not the architect's design intent. So we had to figure out how to form, actual continuous surface from these flat panels. And it's kind of like you want to push one corner in, but of course the panel's not flat anymore. But that does at least give you a strategy to go around the thing.
So how did you do it?
So we ended up turning that, we got a couple solutions here. Play this. All right, 1 second. Okay. So we were going to build this thing with a twist. We're just going to move the twist to only the foam. So everything behind the foam is flat, and then the foam has a flat backside and then twisted front side. So that's fine because we can digitally fabricate the foam, and we've managed that complexity. So, So anyways, that's what we ended up doing, and that's it's using some of those details I showed you earlier, like the handshake connection. That way you have a part of the frame that's actually horizontal. We use holes punched onto the studs as registration for other components that in this case we're using for layout. So you're seeing the whole digitally fabricated system here. Everything was, some kind of file was sent out for every component, and then it was brought together in the shop.
Very cool. Very cool.
Yeah.
So, I mean, this is the whole idea of being able to think about things differently with computational design, parametric design, is it allows you to actually do things you otherwise really just cannot draw or see when you draw, which is then change orders on site. But you're able to fabricate this with precision, either on site or off site, and bring it in and know it's going to fit.
Yeah. I mean, everything's gone together just like puzzle pieces on site.
Right.
I think kind of to one of your earlier points, I think that what's cool about this is that we didn't have to the client didn't have to buy a new machine or anything. All this stuff is using their existing fabrication capabilities. We're just leveraging some of the untapped potential there. So here you're seeing that actual process in place. I like to show the video because it proves that this plan actually does work. I think with some of those animations, it looks like it's a little too polished, but no, that's exactly what has happened. So you had the digitally fabricated frame, the foam, each piece was labeled, came in from the hot wire cutter.
Right.
And then a big thing that we're doing now is digital layouts. This is a Hilti Total Station, which people are probably pretty familiar with that, or something similar where it's shooting points for layout. We actually ran into a ton of issues trying to use the Hilti Total Station on the outside of a big curve, right? It's like it's meant to sit there and shoot straight at a wall or straight at the ground, which is a flat plane. But we're doing it around the surface, which is changing in all directions. It was challenging. So like that's one of the things that, this exploration into new capabilities for things is hard, right? And it takes some experimentation. It takes a couple tries a lot of times. So
to get it right, and then you got to translate that to the people on the ground that have to put it all together.
Yeah, that's a big part of it too. There's absolutely a training aspect, and it usually goes two ways. So there's stuff that we want to bring to the table and help people understand about digital fabrication,
right,
and computational design, and then there's things that these people that have worked for decades in construction, they know what they're talking about. So building rapport with those people, because it's usually a completely different language from what we speak in the software world, is critical, and it's something that we focus on.
I love it. All right, so we're talking about computational design. We're talking about parametric design. You had an opportunity to travel with us as we were shooting, our show on a couple different locations. Tell us a little bit about your experience with that and how your mind started thinking about, wow, how could this work in the offsite world? What potential did you see, and what potential did the people attending the event see that you've been talking to?
Yeah, I mean, it was incredible going around and visiting these facilities last week. Like I said before, I'm trained in architecture and I've spent a lot of time in construction now, but really coming from the technology side of things. And these are people that were, way more deep into the construction side of things and creating mass production offsite, which is something I really hadn't seen firsthand before. So seeing some of the facilities and seeing just the scale of them was a bit mind blowing. And we have a lot of the same goals, which is to make it really efficient to build buildings. And I think we're coming from this, we've really spent a lot of time on the geometry side of things. And, as we're going through all these sites and these shops last week, it's like, okay, I think there's value that we can provide here, but there's still some investigation to how we're going to do that. And that's a big thing that StudIO is focused on moving forward.
Sure. And that's a big thing we're focused on, right? How do we bring new minds, new ways of thinking into the world of modern methods of construction, offsite, industrialized construction, whatever everybody wants to call it, so we can start thinking differently. And that's part of what was so great having you on this journey, Scott, because everybody was pretty much interested in learning how you're doing what you're doing and what's involved in it. And how does that incorporate, or how does that add value to the supply chain to what these other people are already doing?
Yeah.
How do they add more value? And that's what this is about.
No, that makes sense. And they absolutely, everyone that we visited last week was starting to think differently already. I think we can accelerate that and expand that process. So it's a big thing. What we're trying to do is hand that software off to people and then help them understand how they can use it to explore on their own. Yeah,
for sure. So listen, everybody, we were away last week in London, and not just in London. We were in England. We were in the north and the west and the east. It seems like we were all over England, videoing some shows for you. So stay tuned for that. We're going to have a lot of great stuff. Wait until we show you the new tube line that is running through London and how that was built by Bryden Wood. We got a private tour down in the subway station there, or the tube station as they call it over there. And we're going to show you how they printed some of, but not all of, the panels in there and how they did it, all similar to what you're talking about, Scott. Very unique designs and geometric shapes that otherwise couldn't be done by the naked eye or by a drawing. So a lot of really great stuff there. Scott, if you had to say one thing about our trip, or the one thing you learned, what is that one thing you learned about our trip, other than we're all pretty cool?
Yeah, we definitely had a good time. I'm constantly trying to get outside of my comfort zone, and my big takeaway is that some of the unknowns are now known to me. I know what we don't know here at SetIO, and so it's going to be, I know what to go to learn more about, and that's the kind of stuff you're talking about.
That's right.
The kind of stuff we saw last week.
Yeah, it really is. I mean, Steel Horizon that Howick put on, and yes, they are a sponsor of the show, but I mean, credit where credit is due. We had people from the United States. We had people from Czech Republic. There was people from Poland that came in. I mean, all over. I mean, they came from all over. And, funny enough, we were dealing with a tube strike all week, but had the trains messed up or they weren't running. But I think also it may have helped us some, because I don't think they would have enough space. They were packed to the hilt with the people that were able to make it in, and some people were just not coming because of the tube strike.
Yeah, that was incredible. It was standing room only by the time everyone filtered in.
Yeah, and the view was amazing at the New Zealand house as well. So, all right, listen, more of that to follow. We're going to bring you all kinds of details to that trip. Scott, what did I not talk about? Is there anything that I left out? Is there anything you want to leave us with before we wrap it up?
No, I really feel like we captured it all. I mean, there was a lot happened last week, so I'm sure we missed some of it, but we can always come back.
We're not going to talk about the late night walks home at midnight. So we had a lot of fun. Stay tuned. We're going to bring you a lot of videos on that. Scott Mitchell, really appreciate that you came. Stud.io, aka Stud Muffin, but that's a whole nother conversation there. But we had a lot of fun, and we're going to change how we build. And the way we're going to change how we build is by having young, great minds like Scott Mitchell here come into our industry and show us how to do things differently. Scott, thanks for tuning in today and joining us and sharing your knowledge. And the rest of you out there, thank you for joining us, and all of our sponsors out there that keep supporting us day in and day out so we can bring you new and exciting people. We appreciate you as well. And Greg Ugaldi, immediate past chairman and the chairman, and did 2 tours around at the National Association of Home Builders. This is the guy that updates the President of the United States on housing a couple times a year. Unfortunately, had a change of plans today, or he would have been joining us, but we're going to reschedule that as well. So if you showed up for that, stay tuned. It will be happening very soon. All right, Scott, thank you so much. Don't go anywhere. The rest of you, appreciate you for tuning in today. Make sure you subscribe to our YouTube channel. You can see in the ticker down there below. Imagine this, 5,000 hours every month of our show being watched. That's over 5,000 of our shows every month on just YouTube. That doesn't include LinkedIn and all the other channels we're on, watching all the great people like Scott Mitchell over there talk about what they do. I'm Dave Cooper. We'll see you next time. Bye now.